So let's take a minute and examine each of these 5 non-functional requirements that we'll be using in this lesson. After we do this, we will see how each of them influences systems built with different architectural styles. For each quality, we will provide a definition, ways in which the quality might be measured, and some devices that are used to provide this quality. First off, for performance, the Software Engineering Institute's definition of performance is that attribute of a computer system that characterizes the timeliness of the services delivered by the system. And we can measure this in a lot of different ways in terms of response time, throughput, system capacity, system utilization. And there are many devices that programmers can use to improve performance, for example, caching, concurrency, memory management, and so on. The second quality we want to look at is maintainability, and this is the extent to which enhancements can be readily added to a system. This is sometimes also called evolvability, flexibility, adaptability, and so on. The measures, and we've talked about these earlier, are coupling and cohesion, and there's many devices, such as encapsulation, publishing your interfaces, use of subclassing, indirection, and wrapping. The third quality is reliability, and this is the likelihood of failure, of system failure in a given period of time. That is the continuity of service that the system provides. The typical measure for this is called mean time to failure, or MTTF. Some of the devices that can be used to provide a high reliability include redundancy, fault tolerance, and recovery blocks. Software safety is the extent to which a system protects against injury, loss of life or property damage, absence of catastrophic consequences. It can be measured in terms of the complexity of the system, the time coupling, and by fault tree analysis. Some of the devices include hardware interlocks in the case that the particular system has peripheral hardware devices, and fault containment strategies. The fifth quality that we will look at is security, and this is the extent to which the system protects against unauthorized intrusion or provides confidentiality. Security is measured by levels such as confidential and top secret, and sometimes formal proofs are used to guarantee that the system obeys whatever its confidence level is. Some of the devices include authentication, authorization, security kernels, encryption, auditing and logging, and access control mechanisms.